Hi, I'm Adam. This is the Machine Tech video blog, and today I'd like to talk a little bit about the different types of positive displacement pumps. At first glance, there seem to be so many unique designs of positive displacement pump that it can be a little confusing. And it really wouldn't make a whole lot of sense to try and cover every single possibility in this one video. But what I have tried to do is to break it down into 9 basic mechanisms. At the heart of any pump, you'll find one of these mechanisms. I've also tried to show a real-world example of each different type of pump. Each basic mechanism falls within one of 2 categories based on what type of motion it utilizes. We have reciprocating and we have rotary. Reciprocating pumps are the first category. Every reciprocating pump utilizes some kind of expanding and contracting chamber and a series of check valves in order to draw fluid into the pump and then direct it out into the system. To illustrate this concept, let's take a look at pump number 1, the piston pump. The mechanism consists of a reciprocating piston inside of a cylinder with check valves at both the inlet and the outlet. When the piston is on its suction stroke, which is the upstroke in this case, the chamber inside of the cylinder expands, the pressure drops, the check valve on the suction side opens, and fluid is admitted through the inlet. By definition, check valves permit flow in one direction only, so they help to prevent backflow and direct the fluid through the pump. As the valve on the suction side of the pump opens, the valve on the discharge side closes. On the discharge stroke, which is the downstroke here, the piston pushes on the fluid in the cylinder. The pressure rises. The suction valve now closes and the discharge valve opens to release fluid into the system. Here's an example of a common piston pump called an axial piston pump. This pump is a tad more complex than our little demonstration, but the pumping action is generated in exactly the same way. The axial piston pump has multiple pistons equally spaced on the end of a rotating angled plate. As the plate rotates, the pistons are driven into and out of their respective cylinders. You can clearly see the motion here. Like most reciprocating pumps, piston pumps are relatively efficient and they're capable of generating very high pressures. Pump number 2 is the plunger pump. Plunger pumps look very similar to piston pumps, but they work a little differently. Unlike a tight-fitting piston, a plunger fits loosely in its cylinder. Just like when your bathtub overflows because you filled it too full with water before jumping in, the physical mass of the plunger alters the size of the chamber and displaces the fluid. This is a triplex plunger pump, which uses 3 staggered plungers for smoother flow delivery, but it is otherwise the same as our demonstration. Pump number 3 is the diaphragm pump. Unlike a piston or a plunger, an elastomer diaphragm is flexible. When it flexes, it changes the volume of the chamber, causing fluid to be drawn into or pushed out of the chamber. Our example is an air-powered double diaphragm pump. The pump is essentially 2 diaphragm pumps oriented back-to-back with the diaphragms linked by a connecting rod, so it can pump on both strokes. One unique property of the diaphragm pump is that it doesn't require a seal, because the wet and dry sections of the pump are completely separated by the diaphragm itself.